Hello everyone, welcome back. It's day 17. I'm reporting this on it's 19th. I should have reported it yesterday, but okay, I'll be reporting it today. I'll be making another video for day 18, which will be right after this. Uh, okay, and right. So on day 17, what I did was subset some problem. Already discussed that this is the one which I solved on day 16, I guess, I don't remember. And on day 17, I did partial subset sum. Okay, I'll show you how they are similar and what you all need to do in order to complete them. Okay, first of all, let's understand what is 01 knapsack. Okay, so knapsack, what do we call a knapsack? There is this is called knapsack, and in it we can place some items randomly. It doesn't have to be in any particular order, they are just randomly put in. Okay, that is the concept where subset comes from. All right, so suppose you have this array. Okay, and there is this one is the weight array, and let's create a value array. Okay, it should be same length. Hoping it is. Okay, yeah, it's in. So we'll have some values over here and some over here. Then we'll be given some weight, maximum capacity, you can say. Let's say weight. Let's say it's simply W. I mean the maximum weight it can hold. All right. The question is to find the maximum value of this bag. I mean, you can have all these weights, combination of weight which you can put in there, which has more values, then you can, you just have to maximize the value, like how much of items it can hold, which of of those, like suppose you have 2, 3, 4, 5, and the capacity is 7. Okay, so what's the possible values? Like you can get these two. All right, you can have these two, or you can have 4, 3, 7, 3, 2, 5. You can have it like this two, and then these two as well. Okay, but they will be having some values, corresponding values as well. So which one, if we sum up, will get maximum value? All right, so this is the question. Okay, now let's get back to how we can solve it. So this is a TP question. First of all, we need to understand that how does it work. Okay, so let's say this is the array. There are n elements, and these are n minus 1 elements, and this one is n minus 1th element. I hope you are getting what I am saying. Okay, so if how is this question a DP? Because if suppose if we remove this element, then this one should also give us the answer. Like okay, so we'll have a new weight which will be equivalent to suppose if we are considering this value, then we'll have the new weight. Suppose we are considering this value, then we have some value or weight of this element, then obviously if you're taking this element and remove, if you are, there are two cases only. Either we can take this element or not. If we take this, we'll remove the weight from the capacity, because suppose there is a bag, and if you have filled, if its capacity is 10 and you have taken a value and its weight is around 5, so how much will you be able to, let's take another number, say 4. So if you have put in an element which has the weight of 4 and the total capacity is 10, how much is left? 6, right? So this will be the new weight. So we'll be removing the weight of this n minus 1th element. Okay. And then we'll have the n minus 1 numbers. Okay, this one. And again, the same call will happen to find the solution for this condition. All right. This is why it is recursive. Now let's see what would be the base case. So the base case would be, what if there is no element? Sorry, what if there is zero weight and there is zero element? Zero weight and zero value. Okay. So if basically if there are no element in the array, then obviously we can't just, if there is no element, what we gonna put? Nothing, right? So we will return 0 in this case. And uh, if the weight of this, I mean the capacity of this knapsack is 0, then obviously again we can't put anything inside it, right? So in both the situation we have to return 0. This is the base case. All right, now let's see what are the possible cases. So this is the number of elements and weight, and suppose if n minus 1th element, its weight is less than equals to the capacity, and in this case if it is greater than capacity. So if it is greater than the capacity, then obviously we are not going to take it, right? But if it is less than capacity, we can take it, and or we can't. Both cases can happen. Okay, let's see. If weight of n minus 1 is less than equal to capacity, then two things can happen. Return max of, so there will be two things. Okay, two cases, that either we can take it, either we don't. So if we take it, what will happen? We'll add the where is the value array? So we had this, no? If we are taking, if we are taking this one, we'll add the value as well of this one. So we'll add value of n minus 1 plus, we'll again call this knapsack recursion, and then weight array, value array will remain same. What will change? The n minus 1. Okay, see, when I'm saying n minus 1, for this case we are talking about the this index, and when we are sending it here inside the function, we are telling him that this is the number of elements in the array. So don't get confused. And now here we have the capacity, which will be updated to w minus, I mean which is capacity minus weight of n minus 1th element. Okay, this is the uh, first thing where we need to find the maximum. This is the case where we are just uh, taking the value. Okay, we are just keeping this value inside. Okay, and we are putting this value inside the knapsack. This is the first case, and the second case would be when we are not using it, which means basically knapsack, call it again, weight array would be same, value array would be same, and then we would again, if we are not taking, but we are obviously cancelling out this index, right? So we are removing that number, the length will decrease n minus 1, and weight would remain same because we are not using that element. So we are not decreasing any sort of, because if we are not putting any element, then the capacity would remain same, right? So that is why w will just stay here same. Else, or say if it is greater than, okay, we don't need to say, I mean, if simply say else, return this one, okay, because in that case, if it is greater than, where it is, yeah, this one, if it is greater than, then obviously we can't, if the capacity is 10 and we are we are bringing in an element which has the weight of 11, obviously we can't put something which is greater than the capacity, so we are not taking it into the consideration. So yeah, this is what this call is, so we keep it here. So okay, let me keep it a bit clean. So this is all that knapsack is. Let me keep it clean. Say knapsack, okay. We'll say um, weight array, value array, the length, and the capacity. Okay, now the base case. If n equal to 0 or 0, return 0. Okay, this is the base case. Now if weight, okay, say weight and value. The weight of, this was our array, we are picking up the last element, n minus 1th element, and this is, let's not talk about it, otherwise you guys might be getting confused with this n minus 1 and n minus 1 length. Okay, so let's say weight of n minus 1th element is less than equals to this weight, which is capacity. If this is the case, we'll return maximum of, okay, so the maximum of it would be, so I told you about that there will be two conditions, either we take it, either we don't take it. Okay, if we take it, the capacity would decrease by the weight which we have picked up, otherwise the capacity will remain same, and in both cases if we have processed an element, we'll remove that element. Okay, now max of value n minus 1, we are picking up, this is the first case, and then again we'll call that knapsack, this one, we'll say weight, value will remain same, and then n minus 1, weight would be weight minus weight n minus. Okay, I hope this makes sense to you all. All right, now what would be the other case? The other case would be when we are not using any when we are not keeping it into the consideration, so we'll remove the number and the weight will remain same. And else return knapsack weight value n minus 1 w. All right, so this is the function. The return type would be int, because at the end of the day we just want this, like if it will be possible or not, correct? All right, so how can you do it? This was purely recursion, So if you want to memoize it, you can simply do, let's say, um, you can, in the main function where you are calling this knapsack, so there will be a main function where you will be calling this knapsack. Okay, what you have to do is you have to initialize a dp. Okay, the size would be of n plus 1 and w plus 1. So how do you decide what we would be putting inside this dp? All right, so this is, I mean, what would be the size and all would be of this dp array, and what would be the um, dimension of the dynamic, I mean, the matrix which you are using. So it depends on, when you write on the recursive solution, you see that there will be some parameters which will keep on changing, and there will be some parameters who don't change, right? Oh my god, this looks like a face. Lol. Okay, so there will be some parameters which don't change and some which will change. So number of changing parameters is equals to the dimension of dp array, dp matrix, sorry. So here we see that there are two parameters which are changing. So we'll use two-dimensional dynamic dp. Okay, but always remember to keep it incremented with one. I mean, plus one with whatever size you are taking. Okay, and you can pick it up from, like, what's the size you are gonna use. Always use the max size. So how would you know what you would be using? So there will be constraints given to you, like n can be greater than equal to 100. Weight will be just like directly given to you, so you can directly use that, and always make plus one. All right, we'll come to that, why do we need this plus one and all. Now let's see. Okay, so now that we have created this dp, and instead of doing it here, what you should do, you should initialize it outside the main method, so that it can become global and you can directly use it here. And that is why I said use constraint, because um, you already know the max value, right? You don't have to come here and define that, so that it can stay global, and the max size will still be there, and you won't go out of bound and all. All right, so here if you come and you see that um, you can simply say dp of n comma w equals to max dp n comma w equals to this one. So basically you just have to, after return statement, you just, before returning, you just have to equate it. Okay, and now just after this statement, this base case statement, just write if dp of n comma w exists, which means not equals to 0, then return this value. So basically you had memoized it somewhere, okay, in the array. And if you are coming across this again while solving this problem, then it will simply pick it up from here. It won't execute all these recursive calls. So this is the benefit of memoization. So this is recursion plus memoization. This is dp. All right, and yeah, and that is it. So also here, before returning 0, you just have to make it nw equals to 0. Okay, now let's head back to top-down approach. It's simple. I mean, uh, instead of making a recursion call, you would simply do is make it iterative. And you had this dp matrix, That thing will stay same, but you'll have to initialize it. For that, you just need some common sense. 0, 1, 2, 3, 4, 0, 2, 3, 4. Suppose this is the number of, this is the length, this is the capacity. Okay, and if the capacity is 0 and this is 0, would you be able to put it? All right, 0. The capacity is 1, and you have 0 element, again 0, 0, 0. If the capacity is 0, you have 1 element and the value of 1. So it depends, right? So what you have to do is you have to fill this array, the first row and all, okay, on the basis of the question given. And then you would have to go through, you have to make a for loop. Let's come here. Okay. You don't have to return anything, right? You will simply remove these return statement and you will be updating this. Okay. Yeah, so this will remain same. We'll have to fill 0, 0, 0 here. All right. Okay, I'll just clean it up and do it again. Wait. Sorry for the confusion which I may have caused. All right, boys. Okay, so if you see that if we have 0 element, then we can't fill up any capacity. We don't have any element. How are we gonna fill up a bag? Correct. So just put it 0. And if the sum is 0, you can't just make out of any element, right? The capacity of a bag is 0. How would you gonna put anything? You're not even supposed to put anything. So these will be 0. Okay. So let's make a dp array, sorry, matrix, and then we have to initialize it with this. So you would simply then for int I equals to 0, I is less than dp, not even dp, we have n and w, right? N plus plus, and then if we are doing it for this n, so this one is the n. So basically we have j fixed, so dp of I comma 0, right? This is fixed, so we'll do this for int I equals to, let's say j for easy understand, j is less than w, always keep it plus 1 or make it equals to here, and then j plus plus, then dp 0, j equals to 0. Okay, so this is how you initialize the this is how you initialize this dp array, dp matrix. Okay, now what you have to do is you have to run an iterative loop. Guys, give me a second, my dad is calling. Okay, where are we? So we have initialized the matrix, right? This row and this row we have initialized. Now let's run a for loop. I equals to I equals to 1 because we have already initialized the zeroth ones. Size less than equal to n I plus plus for j equals to 1, j is less than equal to w, j plus plus. All right. Now if weight of I minus 1 is less than equals to um, the j, because see the j is weight. Okay, then what you have to do is simply update dp of ij equals to value of okay, this is the case when we are taking up the value. Okay, if that's the case, then we'll take maximum of value I minus 1 plus dp of what we were sending n minus 1 and w minus weight of n minus 1, right? What you have to do is this will become j, this will become, this will remain same weight, and this n will become I, n will become I. Simple as that. Okay, it won't confuse you anymore how to write dp. So it was we were sending I for n minus 1, so it will become I minus 1, and it was uh, j minus wt I minus 1. It will become j minus weight of I minus 1, right? And this is the first thing when we are considering it. Second case would be dp of I minus 1 and weight would remain same, that is j. We are not subtracting anything. Else, the same thing, dp of ij, I mean this one, equals to dp of I minus 1 comma j. And once this is executed, simply return dp of n comma w. If this will contain the answer. All right. So this was all about knapsack 01 knapsack. Now let's talk about subset sum problem. Here we have to find out that if an array is given and we have been given a sum value, suppose 8, this is 1 4 3 4 2 5 8. Okay, we need to find out if there are subsets that can sum up to 8, I mean the sum, then return true, else return false. So how is it different from the previous? I mean, how is it similar from the previous one? We are only having single array, right? But we are having one thing to find out that okay, this is in the previous case we were having a weight, right? Capacity to which we were finding that it will add up to this one, and there will be some maximum value. I mean, to which we needed to optimize. But here we have this. um, maximum value, which we need to check if there are elements who would sum up to um, come out to be 8 when we sum up them. Okay, so how do we approach this? Now, first of all, let's see what code we had written previously and how can we come up for this one. Let's create this basic matrix. Okay. Um, this is 8, the sum, this is the n. Okay, and what we need to find out is if anything would sum up to sum. Okay, let's see. Suppose if there are number of arrays would be 0 and the number of, the sum would we need to find out is 0. So is it possible to find find values that would sum up to be 0? Is there any subset? Yes, empty subset is also a solution for this case. So this way we will say 1. And if we have one element in the array, then obviously again this empty array would still be giving us 0 value, 0 sum. So this is again possible. So all of these are possible. And if you want to say 1, 0, 1, so we need to find the elements that can sum up to be 1 in an array which has no element. Is it possible? No. So it's same for all. Okay. Now using these, okay, now you can simply create a DP. The size would be this n plus 1 and this sum plus 1. Okay, you will initialize it this way. For loop I equals to uh, I equals to 0, I is less than equals to n, I plus plus, and dp of I comma 0 equals to 1. And likewise put it equals to j equals to 1, j is less than equal to sum j plus plus, and then dp 0 of j equals to 0. So we have initialized the array, this dp matrix, right? Okay, now first step is done. Now what we need to do is we need to iteratively call it. Okay, now let me do one thing to make it easy for you to understand. Sorry. Let's go back, let's come here, and can I copy it? Is there a way I can copy it all? No. uh, Never mind. So what we can do is, say simply what I had to do was you would I'll just write down same code there as well. Okay, then we'll see how we can modify it. So for int I equals to 0, I is less than equal to n, I plus plus, we don't need to I equals to 0, we need to start from I equals to 1. And for j equals to 1, int j is less than equals to sum, and then j plus plus. Again same thing, if Um, nums would be this array from where we need to find out the subset. Okay, nums I minus 1, we are picking up that element, and if we are checking if it is less than equal to the sum, then we would say dp of I comma j equals to, see, we don't have value or something here from which we are maximizing it, right? So we don't need that. What we would do it, we would simply access if uh, so there was the cases that we were accessing this n minus 1 element and then checking if it's the what's the weight, and then we were subtracting if we were already using it. So weight minus so w minus weight of n minus 1, right? This is what we were doing when we were picking it up, correct? So dp of um, also I'll tell you why what we were using max before, right? So why we are not using max here, I'll come to that. And dp of n minus 1, so if you remember, because we are traversing through n, so using I, so it will become I minus 1, and then w is nothing but s here, so and this is nothing but j right now, j minus weight is nothing but nums minus n minus 1, which is again I minus 1, right? This is the first case when we are taking it. And now we'll check for if you remember, we were doing max of two numbers, right? So here we, if we have two values 0 or 1, okay, what we need, what would be the max of this? 1, right? So what we need to do is we need to or, instead of doing max we would simply replace it with or. So we'll say or, and then the case where we don't use it, simply, that's it. Else, again this thing, dp I comma j equals to dp I minus 1 j. Okay, that is it. Now you simply return dp of n comma s. It will return if it is, if it if it will be possible, then it will return true, otherwise it will return false. Okay, now this was for subset sum problem. What if there is a problem of partial subset sum? Okay, so the question is that, suppose if you have like n elements, okay, and let's say 1 2 3 1 2 3 1 2, let's say 1, we'll come to that why I changed to 1. What the question is asking is it possible to split in two subsets such that the sum would remain equal? Okay, if you don't get it, so let me do it. 3 3 6 3 9 3 12 12 to 14. So the question is asking if there can be two subsets which can sum up to 7 and 7, right? So okay, so this is the question. I guess the question is clear. Now, why did I change it to 1 from 2? If it was 2, so it would become 15. Now 15, if you divide it into, it would become 7.5. So that would not be possible, right? You can't split two number because these are integers. So you can't say 8 plus 7 because these are not equal, right? And then only it will become, and you can't have 7.5 plus 7.5 here because all of them are integer. So if total sum of this array modulo 2 equal to 1, return false. I mean, obviously it's not possible, right? But if else, just put it in else it is else, I mean, if it is possible, then sum would become total sum divided by 2, right? Now a question is exactly same as what we did in subset sum problem. The updated sum would become total sum divided by 2. That is it. All right, now if you guys are still confused, let me tell you. If you found out that there are some set of elements that were come that sums up to be 7, then if the total sum is 14, then obviously the rest would automatically come up to be 7, right? Then only they are totaling on 7 plus 7 equals to 14. So this just becomes a new problem that uh, the final sum is total sum divided by 2, and we need to found out that if it's a subset exists which can sum up to this sum, which is total divided by 2. So this is again the same problem, right? This which we did here, total subset sum problem. So in this else statement, after updating the sum, you can simply use the above code and write it down here. And yeah, that is it. So these two are the problems. Um, I mean, I covered 0, 1 knapsack. Let me, well, we covered 0, 1 knapsack, and we covered, in addition to it, we covered how to do it with memoization. Then we covered, that is recursion plus TP, and then we did top-down approach, that is iterative DP solution, more efficient, less memory usage because we are not using recursion call stack, right? And then we covered subset sum problem, and then we covered partial subset sum problem. So yeah, that is all for today. Currently I have moved on to write that down and moved to graph, and I've covered, see, I'm completely new to graph, completely, like from zero from scratch I'll be starting. It's not like I have done before and still I'm starting. I literally don't know anything about graph. Even in college I was just limited to adjacency matrix and list adjacency list, oh my god, adjacency list, and yeah, so this is what I'm covering, like what is undirected graph, what is directed graph, what is weighted graph, and all those things. You need to know the basics, because if you know the basics, then there would be some see, the problems, they will be very huge. You can see that problem statement is written very huge, but if you know all the basics, you might be able to come up with the things which you need to like use while coding, and that can simply ease out your solution. So maybe there could be some properties, and if you knew it, then you would simply directly use that property. Otherwise, you would just keep on wondering, like, how do I make use of it, how do I calculate this, how do I calculate that. So basically, like, for an example, if somebody asks you, like, how many edges are possible, right, in an undirected graph, and they have given you vertex, so how would you calculate it? Suppose there is this 1, 2, 3, 4, and they ask you how many vertex, how many edges can be possible. You will say, you will calculate it like this, right? So for this one, it will be 1, 2, 3. So 3 plus 3 plus 3 plus 3. Okay. So this is, but there will be a few cases where it will be repeating, because if you are counting this one, you're again counting for this one, right? So this is twice, so that is why you will simply divide it by 2. It will become 6. So if you use formula 4 into 3 divided by 2, it will come out as 6. So that is why you need to know. So for undirected graph, it will become number of vertex into minus 1 divided by 2. Why we are doing it divide by 2? Because in undirected graph, we can use one edge as double-sided. But in directed graph, you have to do is vertex into vertex minus 1. And when you'll be using directed graph, you have to mention it twice like this. So these two will be different edges, and that is why it won't be divided by 2. So this is number of edges. So that is why I'm saying properties are very important. Don't just directly dump to DFS, BFS, and all those things. And yeah, this is what currently I'm covering, and I'll share where I'm covering it from. It's also a good YouTube channel, and that guy also uh, is very good when it comes to explain. I mean, so far I don't know how much good he will be in upcoming videos, but yeah, so far this is so good. Hope to see you guys again in the next video. Thank you.